Okay, welcome class. This is our first of our mini lectures. So for every module, a module is a chapter in your journal. So for module 1, we're doing chapter 1 in book 3. And that module will take 2 weeks. And so we'll do about half a chapter a week. Okay, so for this first one, we're going to get about halfway through chapter 1 in this book. And so one thing you can do for these, I'm going to try to keep them brief and mini lectures that supplement things that you're reading in your journals or give you a little more practice in seeing someone work those problems and how you think about them. So you can either, as part of those homework assignments, you might want to read the journal first and then watch the video, or watch the video first and then start working your way through the journal, or do them both simultaneously. You can always pause this video at any time, do a couple pages in the journal, get up to speed, unpause, watch a little more, another minute or two in the video. So I'm going to kind of go through what will be about the first 40 or so pages in chapter 1 of journal 3. Okay, as mentioned before, the chapter map, that's a nice one to give you an overview of what's happening. And we're going to just dive right in with chapter 1's title is multivariable functions. And so we're going to, again, as the intro mentioned, work on functions that extend your calculus life beyond just 2 dimensions. And so let's take something that we're interested in. We're all taking this class, we're all concerned, hoping we get A's in it. So let's say that, again, this was life before, and this is what is called an R2 function because there are 2 variables, one input affecting an output. And we said we will spend a lot of time in R3 looking at things like this. 2 inputs affecting a third variable for an R3 function. But we can go beyond that. We talked about general Rn, and we can maybe think about your calculus grade, right? So maybe we don't need always being X and Y's and Z's. Let's say your calculus grade is a function of what things? So you took syllabus quiz, you read the syllabus carefully, so there were things like quizzes. We're gonna have quizzes, right? You're gonna have to do interact with discussion boards and participation with your teammates. What else do we have? Oh, challenge problems, those are a big one. Saw that on the syllabus. We talked a little bit about introduction videos. And what else? Oh, activity pages. I'm sure there's a couple more, but let's just stop there and say, okay, well, what is this now? This is a R5 function, a multivariable function in 5-dimensional space. We can't graph it, but we could still analyze it. And we'll get to that much later in the semester. So that's the beginning of your intro pages. And functions also have domains and ranges, just like they did here. Those definitions extend. You'll read about that on pages 27. And then what we just did was an example on page 29. We gave an example of an R5 function. We gave it in an algebraic form, and we know what each one of those variables symbolize. But you could also do it in a functional form. Maybe your calculus grade is, I just did like, and this is not true, I'm just making this up for now, but it's just an example, 10% of all your quizzes, 10% of your discussion grade, let's say 50% of your challenge problem grade, and what do we need? Plus a 30% more of your activities. So now I've written this in a functional form, and I can say C is still a function of all those things, quizzes, discussion, challenge, activities, and we combine them this way. And then you can evaluate functions just like you did in R2 at a particular point. It's just the point has more values now. And you can put in values for maybe your quiz average was 95. Did great on those discussions. You're awesome. Teammate, always participating. Challenges, 95. Activities, 95, right? And we would plug them into this function. 0.1 times the 95 for the quizzes, plus 0.1 times the 100 for the discussion, plus 0.5 times the 95 for the challenge problems, plus 0.3 times the 95, right? And so we can calculate that and get a calculus grade score. So you'll give examples on page 29, some other functions, R3, R4, R5, just to get familiarity, things that you can plug in. Okay, then the next thing, again, we will spend most of our time here with both analysis and visualization. And so most of the remaining pages in the beginning of this chapter 1 have to do with these R3 functions that we want to visualize. So our goal is to be able to visualize something like this eventually. Z is a function of x and y, and it's x squared plus y squared. Pretty soon you'll be able to, off the bat, visualize that and graph it. You'll be able to see it in 3D and then graph it on a 2D piece of paper. But things could be even more complicated. Maybe we have some signs in there. Maybe it's e to the x plus xy, right? Those maybe, that's not something I'd expect us to be able to graph by hand or visualize, but we'll use a tech tool and to visualize that, and then we'll also be able to by hand analyze that by taking derivatives or integrals. Okay, so we have to take baby steps though, because as I said before, your life was here in the xy plane. And now we've taken a big jump to start looking at three-dimensional space. Because that's new, we're going to take some baby steps, and that's what you're going to do on the first, on page 30, 31, 32, 33. Those, if you notice, are graph paper pages, the background of those, which is your cue that they're activity pages, and you're probably going to be doing something active. And in this case, just to show you how this one works, and you can pause the video and read the steps on your own. I'm just going to jump down to a few things here, though. This book is actually made out of transparency covers, so you can write on it with an Expo dry erase pen. And so the idea of that was that we're going to put our x and our y on there. And now what we're going to do is add a pen or pencil, whatever you'd like to write with. So XY planes are, for us, going to be flat, horizontal. And then we'll put our pencil or pen vertically to represent the z-axis. So there we have a three-dimensional coordinate system that we're going to call our desktop coordinate system. We're going to do a lot of stuff with this. It's an aid in the beginning to help us visualize things. And so in this activity, it asks you to plot some points. And so plotting points is pretty easy. Let's say you wanted to plot at the bottom of the page, it says plot your birthday point. So for me, that's 7/15/75, July 15th. So start with the 7/15 part. So I want to plot 7/15/75. So for the moment, what we're going to do often in this class is say, let's just pretend life wasn't complicated and three-dimensional. It was just back to what it usually was, basic flatland, two-dimensional life. I can plot 7/15, no problem. I've been doing that since probably elementary school. So 7 along the x, let's say that's 7, 15 along the y. I'm at this point here. And then I want to add the third component. Now I'm ready to actually enter a three-dimensional world. So I'll turn it this way. And I need to go straight up from that point, 75 units. So maybe my birthday point's somewhere up here, 7/15/75. As long as I can visualize it in my three-dimensional coordinate system with the z-axis in there, I've got the idea. So that's on page 30. We'll get rid of that one, dry erase, move on to the next one. So on page 30, that activity, you get to expand your world to points. And then the next thing we're going to look at are beyond points. We look at vectors. So that's on page 36. A vector connects two points in three-dimensional space. So again, you could visualize going from your birthday point, mine's over here, to the origin, 0, 0, 0, and that is connected by a vector. And so you'll visualize things and do some analysis on those on page 36. Backing up a few pages, there's something called a coordinate system on page 34, and a finger coordinate system. Another thing that's been really useful for students in the past is to most rooms that you're in have a nice three-dimensional corner. Let's see if I can pivot around here to one of mine. Can we see that? Yeah, the corner of that room there, right? So you can imagine that corner is the origin, and the vertical corner here is the z-axis, and then you also have an x-axis and a y-axis. So it's actually helpful in a room that you're going to be studying in often to go ahead and label those coordinate, the axes. Go ahead and put a piece of post-it note, mark one, decide which one you want to be the x-axis, which one to be the y-axis, and of course the vertical one is your z-axis. And then also put a post-it note and label what are a couple activities that help you define the coordinate planes. So we already talked about back here, our usual xy was the XY coordinate plane. It's a horizontal plane. And then we're going to talk about a couple other ones, which are the Y, Z. So that would be this coordinate plane. And then the x-axis and the z-axis would be this coordinate plane. So they're perpendicular. And you'll get to visualize that with the activities in this section. And I think that's on page 32. As a nice activity to make sure you visualize that, and then you can help yourself by annotating, putting post-it notes in the corner of the room. On page 34, the next nice idea that's going to help you visualize things in front of you if you don't have your journal or expo pen, this is just your hand right here. So this makes a really nice R3 coordinate system. My thumb is the z-axis, and so some students actually could go ahead and label that. This guy's my z. Pick one as your x, and then this other one, put it perpendicular. This would be my y. Right, so I hold them all perpendicular to each other, and I have my axes, and I can visualize certain planes in this space, right? So